Hello.
Hello.
Hi, Diksha Didi.
Hi, good evening.
Good evening. Today we are gonna continue with the examples that we had to see on the macro constants and also the different data types that we have seen. So I'll just share my screen and we can continue now.
Okay.
Right. So can you see my screen?
Yeah, it's visible.
All right. So over here, this is a program to show us the use of macro constants and also this it will show us the size of different data types. So first of all they are printing the size of a character. See, most we'll get 1 byte from it, right? Then we have the char minimum value. So we are using the char min macro constants, that the macro constant char min that is being imported from the limits.h header file, right? And char min will give us the minimum value for a character, that's minus 128. Then we have char maximum value. Char max will give us the maximum value for a character, that is 127. Then size of integer will give us 4 bytes, right? That it will tell us the size of integer, that is 4 bytes. Then we have size of short int, that will give us 2 bytes, because a short int is occupies 2 bytes. Then we have size of long int, that will give us 4 bytes, as an integer is by default long, right? So long int and int are the same thing, so long int will also give us 4 bytes. Then we have the size of signed long int. So the signed long int is also your 4 bytes. Your unsigned long int is also 4 bytes. Your size of float is also 4 bytes. The double occupies 8 bytes, and wcat varies from 2 to 4 bytes, right? So wcat over here in this compiler, wcat is occupies 4 bytes, right? So if we run this, we get size of character 1 byte, char minimum value minus 128, char maximum value 127, size of int 4 bytes, size of short int 2 bytes, size of long int it's showing 8 bytes, right? So size of long int it's giving us 8 bytes, though in long int we see over here they in the table they gave us 4 bytes, but this it varies from compiler to compiler. Now over here in this compiler, this a long int occupies 8 bytes, right? And many other compilers, a long int is the same as an integer data type, and it occupies 4 bytes. So it varies from compiler to compiler, right? Next we have signed long int, that is 8 bytes, as long int is showing us 8 bytes. Similarly, signed long int will give us 8 bytes, right? Then unsigned long int is also 8 bytes. Signed unsigned long int. Long ints are all 8 bytes in this uh, in this compiler. Then we have size of float 4 bytes. We have size of double as 8 bytes, and size of wcat as 4 bytes in this compiler. Right, so this compiler takes long int as 8 bytes, signed long int as 8 bytes, and unsigned long int as 8 bytes, and it also takes wcat as 4 bytes, right? So it varies from compiler to compiler, the memory location every data type will store, will occupy, right? So was that example clear?
Yeah, it was clear.
All right. So great. And now over here, we had a slight confusion yesterday in long int, where it occupies its minimum value is 2 raised to power 63, negative 2 raised to power 63 to 2 raised to power 63 minus 1. So we were wondering why it's 63. So because this is a signed long int, right? So if it was unsigned, then it occupies 8 bytes, that is equals to 4 bits, right? So if 8 bytes is equals to 64 bits, and so 2 raised to power 64, sorry I said 65, just a second, I'll say 64, gives us 184467744, right? So over here if we see, we get 184467744 and so on, right? So this is our unsigned long int, highest value, that is 2 raised to power 64. Now for positive, to divide it into two parts, positive and negative, we have to divide it by 2, right? So 2 raised to power 64 divided by 2 is 2 raised to power 63, right? So that's why it's telling us over here that long int is starting from minus 2 raised to power 63 till 2 raised to power 63 minus 1. And we know why minus 1, because 1 till 2 raised to power 63 will be there. If we only take 2 raised to power 63 as a maximum value, then our 0 won't be an option for our long int data type, but we have to subtract it by the maximum value by 1, so that we can store 0 in our long int. So this is why, that is why over here we are getting 2 raised to power 63 and negative 2 raised to power 63. So
Okay.
yesterday we had a confusion, so I had a confusion, so I just wanted to clear it. So next we have this float over here. So now float, floats values are it handles itself the minimum value and the maximum value of the float. So not going much deep into the float minimum and maximum value. The in the memory there's some part for the the for the numbers after the decimal, and there's some part some memory allocated uh, for numbers before the decimal point, right? So the memory is divided by itself, right? So that some part of the memory stores the decimal the part after the decimal point, and some part of the memory stores the part before the memory decimal point. So it identifies itself like how much memory to give to the decimal the part after the decimal point, and how much memory to give the part before the decimal point, right? So now float, similarly with double, it occupies some part of the memory for your part after the decimal point, and it occupies some part of the memory for the part before the decimal point, right? So it handles it itself, right, that how much part to occupy for the numbers before the decimal point and after the decimal point. All right, so this was the three things I wanted to clear up, and I hope it's clear.
Yes, it's clear.
All right, great. Now we can move on to the next program. We have already seen this program. Now we can move on to the next program. Over here, we are gonna use all the data types. So we are using int a, right? So that is equal to 10. So this will create a normal integers. Next we have short b, right, that is equal to 20, right? So short, we are directly giving short, we are not giving any data type after it. That means it will automatically take it as short integer. So short integer b is equal to 20, so it will show us the value of b also over here. Then we have long c, so it will by default take it as long integer. If you don't specify a data type over here, it will by default take in long integer, right? So it will set the data type of c to be long integer. Then we have long d, right? So it will set the data type as long integer, right? Next we have the floating point data types. So float e is equals to 3.14f. So after float values we give f, the f character. So this is the floating data type. Then we have the double data type, which after which we don't have to give any character. For floats we have to mention f, telling that this is a floating point number. But in double we can just give our decimal value, and that will not be a problem. And then in long double g, we have to give the full number, and then we'll have to give the l character, right? So to create the long double. Next we have the char data types, and here this is where we are learning something new. So char h, we know that we have already used char h, like the char data type in our basics course, right? But w char t for is new for us, and we have to give l before giving the value to w char t, and then we have to give the value right after writing l. Then we have char 16t. So char 16t is basically saying that create a character data type that will occupy 16 bits, that is equals to 2 bytes, right? So the char 16t will create a character data type that will occupy 2 bytes, right? And you have to give it you can give u before it, right? So u represents Unicode, right? So if we see over here, we get 99 and 100. So you will convert whatever value we give over here into Unicode, right? So a small u or a capital U will convert whatever value of character we give into a Unicode character, Unicode number, right? So char 16t is equal to UC will give us the Unicode number, character number for our C character, and the capital U also will give us the Unicode number of character for our D character, right? And this one is char 32T, that means 32. This char data type will occupy 32 bits, that is 4 bytes. This char data type will occupy 16 bits, that is 2 bytes, right? So these are three different types that we are learning over here that we didn't learn in the basics course, right? Finally, we have the Boolean data type, and we have one standard Boolean data type, the bool, which can either have true or false, right? And we can just show its value. Then we have a string data type, that is string. No, using normal string keyword, we create a string data type, and we set it. Its value is always a text value, right? And then we are just printing it out. So we created a variable for each data type that we have seen so far, and then we are printing the values of it. So first we created an integer whose value was 10, then the short integer that whose value was 20, then a long integer whose value was 30, and a long integer whose value was 40. Then we created a float whose value was 3.14, double whose value was 3.14159, a long double whose value was 3.14159, and it was continuing, like it was a big number, right? But the output screen is only showing us some places after the decimal point, right? Next, we have the character data types. We saw char, whose value was A, wchar t, whose value we set as B, right? Then we had char 16t, whose value we set as UC, and basically that means Unicode for C, and the Unicode character, the number or character, Unicode number or character for C was 99. Then the Unicode number or character for D was 100. Then we have the Boolean data types true and false, and then we had the string data type, um, string, right? So these were all the data types that we saw in this chapter. Now we are gonna see the advantages and disadvantages, right? So till now, I hope everything is clear.
Yes, yes.
All right. Yeah, nice. So now we can move on to the text part. Now we have seen the examples. Now we can move on to the details and advantages and disadvantages of data types. So this program declares variables of various data types, assigns values to them, and then prints out their values. The integer data type includes int, short, long, and long long. These data types represent whole numbers of varying sizes, right? So whole numbers in maths is like 0 till infinity, but over here in int we can also store negative values. So whole numbers, I believe, is a wrong term over here to use, right? Then we have the floating point data type, which includes float, double, and long double. These data types represent real numbers with varying levels of precision. The character data type includes char, wchar t, char 16t, and char 32t. These data types represent individual characters of varying sizes, right? Next, we have the Boolean data type, that is a simple data type that can only have one of two values, true or false. So it can either store 0 or 1, or true or false. Then we have the string data type, that is a sequence of characters. So it's many characters clubbed together. In this program, we use a string class to declare a string variable and assign it a value. So over here, we included a string class, right? So we included the string file to use the string character, string data type, but we could have used the string data type, basic methods on the string variable, or we could have done basic operations on a string variable without including the string file. We include this to do complex and many more operations on string data types, right? So right now it wasn't required when we only had to create a string data type variable and we just had to print the value of it. Right now the including the string file was not required, but in future when we have to use many methods on strings and all, and we have to do operations on strings, then we'll have to include this string file. Now we are on the advantages and disadvantages of our C plus our data types. So let's first look at the advantages and then the disadvantages. So advantages: data types provide a way to categorize and organize data in a program, making it easier to understand and manage. All right. So one of the advantages is that it's a way to categorize and organize data in a program. Right. So it is easier to understand. So each data type has a specific range of values it can hold, allowing for more precise control over the type of data being stored, right? So you are able to control how much data you have to store in a memory, right? You're not just if you don't specify like in languages like Python, you don't have to specify the data type, and you can keep any value for your variable, and that is kind of, you can say, misuse of your memory, or it's a you're using the memory, you're overusing the memory. Yeah, so it's a overuse of the memory in when you don't have a specific range of values, and you don't have a specific data type definition, so you don't have to define the data type and for variables in Python. So that will at some point lead you to overusing the resources provided by Python, and or overusing the library, the memory of your computer, right? So C plus the advantage of specifying a data type is that you have a specific range of values it can hold, allowing for a more precise control over the type of data being stored. So next we have, data types help prevent errors and bugs in a program by enforcing strict rules about how data can be used and manipulated, right? So there are strict rules when defining data types. You can't say an integer value is equal to string. So if you create a variable in Python, you can just directly say x is equal to 10, and then at some point you can say x equals to hello world, and it won't make any difference. Like it will change an integer variable from integer to string. But in C++, there are strict rules. You cannot say like int x is equal to 10, and you can't say then x is equal to hello world. That will lead to an error, and that will bound you to uh, uh, follow the rules that are given by the data type. So you'll have to follow the rules that data types have defined, and that helps prevent errors, right? So at some point in Python, if you if you have a variable with integer data type, but by mistake you change it to string data type, then it may be very difficult in a long program to figure out the error in your program. But in C++, there are strict rules. So if you have an int x equals to 10, and you say x equals to hello world, that will directly bring an error for you, so that you can correct your mistake and just don't change data types from one data type to another. Next, we have C++ provides a wide range of data types, allowing developers to choose the best type for a specific task. So you have so many data types in every category. For integers, you have so many data types like int, short int, long int, right? For decimals, you have so many data types: double, float, long double, right? And you for your char, you have so many data types: char 16t, char 32t, and you have wchar. So there are so many data types. C++ provides a wide range of data types, allowing developers to choose a best type for a specific task. Now there are some disadvantages also of data types, that using the wrong data type can result in unexpected behavior and errors in a program. So if you specify a different data type and you want to use a different data type, there may be unexpected behavior or errors also in a program. Yeah, right. So some data types, such as long doubles or char arrays, can take up a large amount of memory and impact performance if used excessively. So, like long doubles, char arrays, like long doubles take 12 bytes, char arrays take they take a lot of memory, so they can impact the performance of our program also. So C++ complex type system can make it difficult for beginners to learn and use the language effectively. So there are so many data types that for beginners it may be difficult to understand or learn all of these data types, right? And that's one of the disadvantage. and the use of data types can add additional complexity and verbosity to a program, making it harder to read and understand. So it adds complexity. So if you say wcat x is equals to 10, right, and later in 6 months or in a year you refer back to the program, then you won't recall immediately, you won't recall what wcat was actually, right? You'll have to refer some to some sites or some docs to actually remember what you yourself wrote, right? So it adds complexity and it's harder to read and understand. If you read someone else's code, it may be harder to read and understand that code, right? So now we have reached the end of our data types chapter. We have come to the end of our data types chapter. Now we can move on to the variables chapter, where we are going to see many advantages, disadvantages, rules, etc. for variables, right? So here we learned many data types in the data types chapter. Now we can move on to the next variables chapter. All right, so if you have any doubt, please feel free to ask, and uh, or else we can just move on to the variables chapter.
Yeah, it's clear to move on.
All right. So now we are on variables. So variables in C++ is a name given to a memory location. So variables, what exactly they are? They are a name given to a memory location, right? So if you have a memory location where some values can be stored, you're just giving it that memory location a name so that you can refer to that value stored in that memory location, right? And it makes your tasks easier. Variables, when giving custom names to memory location, it makes your tasks easier, right? So it is a basic unit of storage in a program. So it's the most basic unit of storage in a program, right? And you have many types of storages, like you have database storage, and you have many types of storage which you can do, but it is a basic unit of storage in a program, right? A variable is a basic storage unit of storage in a program. So the value stored in a variable can be changed during program execution. So these are the features of variables, that it can be changed during the program execution. A variable is only a name given to a memory location. It's only a name given to a memory location, and all the operations done on the variable affects that memory location. So any operation that you do on a variable, that will affect the memory location that the variable refers to. And in C++, all the variables must be declared before use. So here we will have the concept of declaration, initialization, and definition of variables, right? But there's one point that in C++ all variables must be declared before use. So how to declare a variable? A typical variable declaration is of the form. That declaration is that first you give the type and the variable name, right? So it will be allocated a memory location, and then uh, you have multiple declaration of variables, declaration of multiple variables, that you give the type, and you create variables of that type. So over here, variable 1 name, variable 2 name, and variable 3 name are of data type, whatever you specify data type over here, right? So if you specify int, so all the three variables you are defining in the same line, or declaring in the same line, will be of integer data type, right? So we are gonna go in declaration, definition, and initialization in deep, right? So let's just continue, and over here, in right, so in declaration and definition we are gonna go in deep over here in this part. But let's just continue reading over here. So a variable name may consist of alphabets, numbers, and underscore characters. However, the name must not start with a number. The variable name cannot start with a number, and it can only contain alphabets, numbers, and underscore characters. So for example, we have a variable in C++ int, that is the data type. Then we have age, that is the variable name, right? And finally we have 15, right? So over here, this is the structure of our RAM. So in our random access memory, uh, we have a memory location where our 15 is stored, and this memory location is named age, right? So this memory location where 15 is stored is being named age. right? So this is the structure of a variable, right? So in the above diagram, the data type is the type of data that can be stored in the variable. Variable name is the name given to the variable, and value is the initial value stored in the variable, right? If you don't want to specify value, it's not a compulsion to store a value. By default, C++ will allocate a memory location to your age variable without giving it a value, right? And whatever memory location it is allocated, there will be some garbage value in it, right? Which may not have been collected, right? So there may be some garbage value initially in your variable. So if you just create int age, right, and then you try to print the value of age, you may get some garbage value that is already there in the memory location allocated to the variable, right, when not initializing the or not giving the value to your age variable, right? So here are some examples: declaring the float variable like float simple interest. Then we have declaring integer variables, right? We are creating multiple integer variables in the same line, like int time and speed. Then we have character variable var, right? This is declaration of a character variable, right? So we can also provide values while declaring variables. So we can say int a equals to 50, b equals to 100, float f is equals to 50.8, and char c is equals to z. So directly you can also provide the value to your variable when declaring. All right, so next we are on rules for declaring variables. So the name of variables contains letter, digits, and underscore. So it can only contains letters, digits, and underscore, no other character, right? So the name of the variable is case sensitive, right? So it's a case sensitive name, right? So like for example, your x in capital, your x variable or in capital, and your variable in small letter will be two different variables, right? So those are case sensitive. So the name of the variable does not contain any white space, so it cannot contain any white space or special characters, right? Next, we have that all the variables names must begin with a letter of the alphabet or an underscore. So it should always begin with a letter of an alphabet or an underscore, right? We cannot use C++ keywords, example float double class, as a variable name. So you cannot say float, right? So that float, you cannot you these like float, like these keywords that you use to define the data type, like float, double, bool, and all, you cannot use them as your variable names, as they are reserved keywords for your C++ language to create data types and work with other things, right? So you cannot use C++ keywords that are already defined in C++ to perform certain actions. You cannot keep them as your variable names, right? So valid variable names are int x, int underscore yz, and int z40, right? And invalid are 89, like a space b and int double. So over here, why is this invalid? Because it's starting with a number. Why is this invalid? Because it has a white space character. Why is this invalid? Because it is using a keyword that is reserved for C++. So it's naming the variable double, and double is a data type, right? So double is a keyword for our data type, for creating a double data type. So we cannot keep the C++ keyword as double, right? So this will lead us to an error. So now we are on difference between variable declaration and definition. Now we are going to see the difference between declaration and definition of variables. So a variable declaration refers to the part where a variable is first declared or introduced before its first use. So when you declare your variable like int a, float x, that is known as your declaration. A variable definition is a part where the variable is assigned a memory location and a value. So when the variable is given a memory location and a value, that is known as variable definition. So most of the time, variable declaration and definition are done together. Most of the time, variable definition and declaration are done together, right? So let's see the following C++ program for better clarification. So now over here in this program, we can see that here we have a variable whose declaration we are doing over here, int a. So this is a declaration. Int a is a declaration, right? But afterwards we are saying a equals to 10. So that's initialization of A, right? So initialization of A, how is it? Because it's being assigned a memory location, and it's been given a value. Given a value, so A equals to 10 is a initialization of A. Then we have b equals to int b equals to 20. So this is a definition. This is declaration plus initialization is called a definition, right? So this whole thing is a definition, as this is the declaration part and this is the initialization part, right? Then we have char a123 equals to a. This is declaration and definition, right? So this is also your, you can say this is also definition, as we have declaration plus initialization. This is the declaration part, this is the initialization part, right? So this is also our definition. Now float C. Here's where the interesting part comes. This is saying this is also both declaration and definition. So this is saying that float C is both definition and declaration. But how? Float C is only the part where we are just creating the variable and we are not giving it a memory, or we are not assigning it a value or memory location. Then how is it declaration and definition both? Because whenever you create a variable like int a, char x, float c, then what happens, your variable is given a memory location. At that time only your variable is assigned a memory location, and it is been given a garbage value in that memory location. Whatever garbage value is there, that is the initial value of your variable. Whenever you say like float c, so the initial value of your variable will be there will be a memory location allocated to the variable, and also the initial value will be some garbage value that is already present in that memory location, right? Then we have int underscore c, d45 and e, that is declaration and definition, right? So over here we have seen three things, three terms, we'll say: definition, declaration, and initialization. Declaration, when declaring, it's the part like int a, int b. So this is the declaration part. But de- what is the initialization part? When the variable is being assigned a memory location and value. Now every variable is by whenever declared is allocated a memory location, and whatever value, garbage value is there in that memory location, the that value is the variable's value, right? So by when declaring, we are not just declaring, we can say that we are doing definition. That means we are when declaring a variable like int a, we are doing both the things, declaration plus initialization, and that is called a definition, right? So this was basic concept of declaration, definition, and initialization, and I hope it's clear. Hello.
Yeah, it's clear.
All right. Next, we are on types of variables. So there are three types of variables based on the scope of the variable in C++. So now scope of the variable is basically the accessibility of your variable. Like a global variable can be accessed from from any part of the program. A local variable can be accessed in the block only, right? So we are gonna see all the types of variables in our C++ language. So the types of variables are local variables, instance variables, and static variables. So our static variables are variables before which we give um, before which we give static keyword, so that creates a static variable. Now static variable, if you remember, we have done the concept of classes in C++. So we saw that we have to create an object of our class to access any of its properties or methods. Well, it's different in static variables. Static variables are accessed directly by the class. So instead of creating an object to access static variables or methods, you can directly say gfg.a, right? And you will be able to access your a variable. You can't do that with b, right? You cannot say gfg.b, right? That's an instance variable. You can only access b from your object, but your static variable, that you can access directly with the class name. So you can say gfg.a and you will be directly able to access your static variables, right? Next we have int b, that is an instance variable. Now, an instance variable is a variable which you can access after creating an object of your class. So when we create an object of a class GFG, then we will be able to access the B variable on that object, right? And the one more point over here, static variables value is the same for every object of our class, but the instance variables value is different for every object of our class, and we are gonna see that in action when we are gonna reach to the classes and all chapter, right? And finally, we have the local variable. Local variables are only accessible, mostly only accessible inside the function they are defined in. So int c is a local variable that is only accessible inside the function it is defined in, right? So we cannot access it outside this function in which your local variable is defined in, right? So these are the three types of variables: static variables, instance variables, and local variables. So let us now learn about each of these variables in detail. So local variables, a variable defined within a block or method or constructor is called a local variable. So any variable defined under a block means under curly braces, right? So under the function's curly braces, or a function or a constructor method is called a local variable, which is only accessible inside its block itself, right? So these variables are created when entered into the block or the function is called, and destroyed after exiting from the block or when the call returns from the function. So these variables are created when for example, when you call the function, so when the function starts executing, these variables are created, but when the function ends executing, these variables are destroyed, right, and are no longer available for use. So the scope of these variables exists only within the block in which the variable is declared. Like we can access this variable only within that block. So we can only access the local variable inside its block, right? And initialization of a local variable is mandatory. So initialization of your local variable is mandatory, right? So next, we have instance variables. So instance variables are non-static variables. So non-static are variables which cannot directly be accessed on a class name, right? And are declared in a class outside any method, constructor, or block. So instance variables are those variable are non-static variables and are declared in a class outside any method, constructor, or block. So it's declared outside any method, constructor, or block. Like over here, it's not defined in any constructor method. It's only defined in the class, right? So that's an instance variable. So as instance variables are declared in a class, these variables are created when an object of the class is created and destroyed when the object is destroyed. So these variables will be created for our object when the object of the class is created. So whenever we create an object of class GFG, the B variable, that is the instance variable, will be created for the object, right? But it will be destroyed when the object is destroyed, right? So unlike local variables, we may use access specifiers for instance variables. So unlike local variables that are only accessible inside a block, we may use access specifier like public, private, protected, that we saw in the basic course also for our instance variables. If you do not specify any access specifier, the default access specifier will be used. And we remember the default access specifier is private, right? Then initialization of instance variables is not mandatory. So the initialization of instance variable is not mandatory, and instance variable can be accessed only by creating objects. It can be accessed only by creating objects, right? Now we are on static variables, which we will continue in the next class as the meeting is about to end. And I hope you like today's class.
Yeah, thank you.
Thank you. I'm
Okay.
not sure we'll have a meeting tomorrow. Uh, we can have it day after, or we'll discuss on WhatsApp. Okay. Bye.